Hi everyone, in this video we are going to see a very interesting property of triangle that says reflection of the orthocenter lies on the circumcircle of the triangle. Let's suppose we have a triangle like this, triangle ABC, and then I have dropped two perpendiculars from two vertices, right? From vertex A, I have dropped a perpendicular that landed at point D on the side BC, and similarly I dropped another perpendicular from the vertex B onto the side AC and it landed at point E. So the point of intersection of these two altitudes will give us the orthocenter, and I have denoted that as point H. Next, I am going to take the reflection of point H on the side AC, and let's suppose the image of H is the point H prime. Next, I am going to join A with H prime, and then we are going to look at these two triangles, triangle AEH and triangle AEH prime. Since H prime is the image of H, it will be at the same distance from the reflecting side. That means EH will be equal to EH prime, and also the angle AEH will be equal to the angle AEH prime, and of course each of them will be equal to 90 degree. That's from the property of reflection. And then of course AE is the common side for those two triangles. So then we can clearly see that these two triangles are congruent triangles. And because they are congruent triangles, we can say angle AHE will be equal to angle AH prime E. And let's suppose it is equal to alpha degree. And that will also be equal to the angle BHD, because angle BHD and angle AHE, they are vertically opposite angles. So they will be equal. And can we write angle BHD as 90 degree minus angle HBD? If you look at the little right triangle HBD, there the angle BHD plus angle HBD, they will be equal to 90 degree. So we can say that angle BHD can be written as 90 degree minus angle HBD, and then angle HBD can be written as B minus angle ABE. And then if we remove the parenthesis, we can write it like this. It becomes 90 degree minus B plus angle ABE. And then if you think about the angle ABE, it can be written as 90 degree minus angle A. If you consider the right triangle ABE, there the sum of the angles ABE and angle A, that will be equal to 90 degree. So we can say that angle ABE can be written as 90 degree minus the angle A. And from here, if we remove the parenthesis and reorganize the terms, we can write it like this. And then we can write A plus B as A plus B plus C minus C. And of course A plus B plus C is equal to 180 degree, because that's the sum of the interior angles of a triangle. So that can be written like this. And then if we remove the parenthesis, it is going to look like this, which is essentially the angle C. So we are able to prove that the angle AHE, which is equal to the angle AH prime E, which we consider as alpha, that is same as the angle C. Now if we draw the circumcircle for this original triangle, it could look like this. And if you look at this circle carefully, you see the angle AH prime B is same as angle ACB. We know from the properties of circle that the same chord subtends same angle on the same side onto the circle. So here, if we consider AB to be a chord for this circle, we can clearly say that this circle actually passes through A, H prime and C. And of course, it will pass through A and B because we have considered AB as the chord. So essentially, this circle is passing through all 4 points A, B, C and H prime. That means we are able to prove that the image of H, which is H prime, is also located on the circumcircle of the original triangle. I hope everything made sense. Thank you for watching. See you in the next video.